everyone. This week we're going to finish up the breaking the array strategy that I taught before our break. And this week I'm going to dive into some division and show a new strategy with this Flipping the Classroom video. So I first want to look at a basic algorithm for division. This is the way you and I were taught in school. Notice when we go through it, can 3 go into 4? How many times? That 1 time. 1 times 3 is 3. I subtract, get a 1. You pull down that 8. What times 3 gives me 18? That'd be the 6. 6 times 3 is 18. I subtract, and I have no remainder. So kind of going through this, it really does not explain really your numbers and what really is happening here, because there are arrays or multiplication that is used to actually find your answer, your quotient. So the two arrays that are actually being used here is a 3 by 10 and a 3 by 6. Going back to that breaking the array, that's what you just did. There's your 16, and then there's your factor of 3 here. So really when I say 3 can go into 4 how many times, I'm really looking at what larger number can get me close to 48, and that would be the 10. 10 times 3 is really the 30 that I'm looking at here. So instead of really the 3, it's actually that 30. Then you subtract and finish it out. But a lot of students do not know this, and so before I teach this algorithm, I want to show them this DQ strategy to help them. And this is essentially the same exact thing. I'm showing how to use arrays or multiplication to find the answer, and all I've done is I've organized it in a chart. So DQ strategy, divisor quotient strategy. Here's my divisor, here's my 3, and then I'm going to times it by something that will eventually build to my quotient to get me back my total. So 3 times what gives me close to 48? I always tell my kids your starting quotient number, use your 10s, because kids are still learning their multiplication facts, but 10s seem to be pretty easy for kids to understand. So I wouldn't say 3 times 20 here, because that's going to give me a 60, and we know we can't take 60 from 48, so I'm going to have to stick with 10. So 3 times 10 is 30. I'm going to subtract, which is what I'm essentially doing here. I'm really subtracting a 30 here, and I get 18. So 3 times what gives me 18? Well, it's 6, just like up here. 3 times 6 is 18 with nothing. 3 times 6 is 18 with 0 remainder. So to get my quotient, I add the 10 and the 6 to get 16. So again, I use the 3 by 10 and the 3 by 6 to find my answer using a DQ strategy. There are other ways you can do DQ strategy. I always tell my kids it depends on what you start with as your quotient. The journey might be different than someone else as long as we have the final product that's the same, or the final answer that's the same. So one student might not use their 10. Maybe they like their 12s. So they may say 3 times 12 can get me close to 48 by using the product of 36. So when they subtract, they get a 12. So then 3 times 4 gives me 12. I subtract, get a 0. And if I add that 12 and 4, again, I'm still getting the 16 with no remainder. I just used a 3 by 12 and a 3 by 4, as opposed to this student that used a 3 by 10 and a 3 by 6. Once your child gets really good at this, and eventually they will, they may automatically know and can work it out that a 3 by 16 actually is a 48, and that there is no remainder. So it literally only took them one step to figure out that 16 was going to be your quotient and no remainder left over. So again, 3 different ways that you possibly could have solved it to get the same result. I'm also going to be showing how to use this strategy with remainders. So again, I will show them the algorithm and down the line, but again, going through that process, we go through, can 4 go into 1? No. Can 4 go into 13? Sure, it can go 3 times, but that's not really what you're saying. You're really saying, I can say 4 times this 30, that can give me this 120, which is really essentially what I'm doing. So I'll get a 120 here, subtract with a 17, and then, what number times 4 gets me close to 17? Well, it would be a 4, which is that 4 by 4, 16. When I add those two, I'm going to get a 136. But I know that I have to go back and add, there must be a remainder, which in an algorithm, it's going to show me this to get back my total of 137. So essentially, I am still using arrays in this algorithm to get my final answer here of 34 remainder 1. So I'm showing this exact same step here, just using that DQ strategy. So again, having my kids use their tens. So in this case here, 4 times what gets me close to 137? It would be 30, which gives me 120. I subtract, 4 times 4 is 16. There's my remainder, 30 and 4, there's my quotient. So again, I used a 4 by 30 and a 4 by 4. I had to go back and add that 1 because I have to get back my final total that I was using to divide. So a student might use a 4 by 30, or maybe they like a 4 by 20. If a student chooses a 4 by 20, that's okay. Their journey is just going to be a little bit longer to get to the answer. They're going to have 3 arrays and having to go back to add 1 to get my answer, whereas this student only had to have 2 arrays to get my answer. So again, it did not matter the journey that they took here, as long as they have the same answer at the very end. So again, essentially what I want the students to understand and know is that you are still breaking arrays and using arrays to actually find division. But again, when you're teaching this algorithm, it doesn't really teach this to the kids. You know, they're just told to subtract and bring down, you know, but they don't really understand why. So this strategy really shows them why. And eventually, like I said, we will use the basic algorithm when they feel very comfortable with the DQ, and they'll be able to use a more efficient strategy then. I hope this is very helpful, and I'll be sending some more videos out very soon. Thanks so much.